In this video, we'll look at the example of building the confidence interval for population proportion manually and using StatCrunch. Let's read the example. Use the sample data and confidence level given below to complete 4 parts. A drug is used to help prevent blood clots in certain patients. In critical trials, among 4,789 patients treated with the drug, 183 developed the adverse reaction of nausea. Construct a 95% confidence interval for the proportion of adverse reactions. Part A. Find the best point estimate of the population proportion P. The best point estimate of population proportion P is simple proportion, P hat. To find simple proportion, we simply divide X, the number of successes, by the total number of observations. The number of successes in this case would be 183 people who developed the adverse reaction of nausea. The total number of patients treated is 4,789. So we divide 183 by 4,789. Let's use the calculator. 0.038 rounded to 3 decimal places. Well, let's have this number written down somewhere because we will use it later also. Fantastic. Next part, identify the value of the margin of error E. The formula to find the margin error E is E equal Z of alpha over 2 times square root of P hat times Q hat divided by N. Well, we know P hat is 0.038. To find Q hat, we simply subtract P hat from 1. Q hat is equal 1 minus 0.038 is equal 0.962. And we also know N, the total number of patients. We just need to find Z of alpha over 2. To find Z of alpha over 2, we'll use StatCrunch. Before we use StatCrunch, let's do some sketch. We're looking for a 95% confidence interval. So confidence level will be 0.95. Z of alpha over 2 is that critical value that separates critical region on the right of that value from non-critical region on the left. To find that critical region, we would subtract 1 minus this part, 0.95, and divide it by 2 because we have 2 tails. That will give us 0.05 divided by 2, 0.025. Let's open StatCrunch. In StatCrunch, we go to Stat, Calculators, Normal, change the area to the right of the z-value, and enter that area that we just found, 0.025. Compute. The critical value that separates the critical region on the right from non-critical region is 1.959964. Let's round it to 2 decimal places, 1.96. So now we know all ingredients in this formula, and we can proceed with finding E. E is equal Z of alpha over 2, 1.96, multiplied by the square root of P hat, 0.038, times Q hat, 0.962, divided by N, the total number of patients, 4,789. Let's use calculator. The margin of error E is 0.005415. We need to round it to 3 decimal places. So E is 0.005. Let's check. Awesome. Part 3, we need to construct the confidence interval. To construct the confidence interval, we would subtract the margin of error E from the value of P hat on the left and add e to the value of p hat on the right. Let me do the calculations on the right side of the screen. Let's enter the confidence interval limits that we just found. And let's check. Well done. In a minute, I will show you how to check your work on StatCrunch. But for now, let's answer the last part of the question. Write a statement that correctly interprets the confidence interval. To interpret the confidence interval, we say that one has 95% confidence that the interval from the lower bound to the upper bound actually does contain the true value of the population proportion. It's the last choice, D. Let's check the answer. Fantastic. Now let me show you how to find the confidence interval on StatCrunch. We'll go to Stat, Proportion Stats, One Sample, with Summary. Enter the number of successes. It was 183. The number of observations, 4,789. Make sure that the confidence interval level is correct. In this case, it's 0.95. Compute. The lower limit is 0.0327 rounded to 3 decimals, 0.033. That's what we found, right? The upper limit is 0.0436. Rounded to 3 decimals would be 0.044. But we were pretty close. Just 1/1000th of a difference. I hope that was helpful.